This is problem 21 from the 2023 AMC 10A. Let p of x be the unique polynomial of minimal degree with the following properties. And then there are a few properties listed here. The roots of p of x are integers with one exception. The root that is not an integer can be written as m over n, where they're both relatively prime. Find m plus n. So let's use this. Of course, this is going to be the most important information. Let's start from the top. If p of x has a leading coefficient 1, that just means that the leading term will have a coefficient of 1. So let's just keep that aside for now. Now 1 is a root of p of x minus 1. So if we plug in 1 over here, p of x minus 1 is 0, right? P of 1 minus 1 equals 0, which means p of 1 is simply equal to 1. So that might be useful for us, but not right now. So let's look at the rest of the stuff. We'll just keep this aside. 2 is a root of p of x minus 2. So if you plug in 2 over here, you get p of, well, 2 minus 2 equals, is a root. So this equals 0, which means 2 is a root. Sorry, this becomes 0. So 0 is actually going to be the root. 2 is not a root over there. 0 is the root. And if 0 is a root, what does this tell us? This tells us that one of the factors is x. So x is a factor. Okay, so that's, at least that's something useful that we can use. Let's look here now. 3 is a root of p of 3x. What does this tell us? That tells us very similar process. 3 times 3 equals 0. This gives us 9 as a root. So 9 is a root. Exact same process as before. And this time we see that now if 9 is a root, x minus 9 is going to be a factor. Is a factor. So I'll just do that. And now again, now this one, pause and try it on your own. Okay, with this basically tells us that if 4 p of x has a root of 4, p of x also has a root of 4. So that tells us that p of 4 equals 0, which means 4 is a root, which means x minus 4 is another factor, So now we've got 1 factor, 2 factors, and 3 factors. And we also, these are the only factors we know. What else do we know? We know this thing, p of x has a leading coefficient 1. And we also know this important thing over here. So let's piece this all together. Okay, let's go. So we know that it's going to be x times x minus 9 times x minus 4, right? Now there could be a coefficient in front, but because the leading coefficient is 1, we can't put any number in there, right? And it's also minimal degree, so we can't put any x down there. Basically, we can't add anything to this, right? We can't put like a 5 in front, then the leading coefficient won't be 1. And if we put any other factor, it won't be minimal degree. So this is all we have now. Now we just need to use this. So if we use this, we can just plug in 1. This is literally p of x, right? This is p of x. And then remember, the roots are all integers with one exception. So there is one more exception. There is one more root, and let's call that a. So x minus a. Now let's use the same thing again, exact same, except now instead of writing 1, we're going to plug it in here. So we get 1. 1 minus 9 is negative 8. This is 1 minus 4, so that's negative 3. And then this simply becomes 1 minus a. Okay, so if we've got this, well, what does this multiply to? And remember, this is still all equal to 1. Don't forget that. So this basically, if you simplify this, I'm going to work right here on top now. This gives us 24 times 1 minus a is equal to 1. So this must be 1 over 24 then, right? And if this equals 1 minus a, then a must equal 23 over 24. Now that's obviously not an answer, right? These are all pretty big numbers. So what are they asking us for? Well, they're asking us for m plus n, where m is a numerator and n is a denominator. Of course, these are both relatively prime. So we've got m, we've got n, add them up and we get 47. So the final answer is D.